G'day and welcome to another Visions of Chaos tutorial. This tutorial will be covering Physarum simulations. I saw a few comments in my YouTube Physarum videos saying this blog post was difficult to follow, so hopefully with some more detailed explanations it will help those who want to use Physarum simulation modes within Visions of Chaos or possibly coding your own Physarum simulations. To get an idea of what the real physical Physarum slime molds can do, I really recommend you pause this tutorial now and go watch the few videos I linked to in my blog post. Slime molds are really unique and fascinating organisms, and I think that if you watch these quick intro videos, you will have a greater appreciation for them. If your time is short, skip them. Okay, I hope you found those videos interesting. Now we can begin understanding how these simulations of slime molds work. My simulations are based on this blog post by Sage Jensen here. Referring to this paper by Jeff Jones, which if you are interested in, you can download. It's not behind a paywall or anything like that, so it's free to have a look. On Sage Jensen's page, he gives this diagram to explain the steps of how his simulation works. So I think if we go through this and just check each step, it should make it a lot clearer how these Physarum simulations work. These two regions represent the 2D world the simulation runs on. Particles representing the individual Physarum organisms move around in the world depending on levels of pheromone trails around them. Each of the particles senses 3 spots that are directly in front of it and to the left and right. Particles have a heading angle, which is the direction that they are moving in. They also have a sensor distance value, which determines how far ahead of themselves they can sense the pheromones. They also have a sensor angle, which determines how far to the right and left they can sense the pheromones. Using the particle heading, sensor angle, and sensor distance gives you these 3 spots in the simulation world. The particle then determines the pheromone concentrations at each of these 3 locations. Depending on these concentrations determines which way the particle rotates. So this first image here indicates that if the pheromone concentration directly in front of the particle is the strongest, then it does not turn to the left or right and keeps moving straight ahead. This second picture shows that if the pheromone concentrations to the left and right are greater than the forward concentration, it will pick a direction randomly. And these last two mean that if a pheromone concentration is greatest on the right, it turns to the right. If a pheromone concentration on the left is greatest, it turns to the left. And so that determines which way the particles turn based on the pheromone trails. Step 3 for the particles, they then move forwards in the new heading direction. Step 4 is a pheromone deposit step. Once each particle has moved, it leaves a pheromone on the current world. So at the end of this step, all of the particles have sensed their neighbouring cells, turned, moved forward, and then deposited an amount of pheromone at their current locations. Once all particles have moved, step 5 diffuses the pheromones to their neighbour spots. So this is basically like a blur routine that spreads out the pheromone concentrations. In this small picture here, say you had that central pixel had a value of 9, all of these surrounding pixels had a value of 0, the 9 would evenly spread out to these neighbouring spots, and so you'd have 111, 111, 111. And all the decay does is it subtracts a small amount from all of the pheromone values. This represents the pheromones evaporating or drying out over time. Once step 6 is done, you can start all over again. And so the particles, again, they sense their forward spots, determined by their heading, sensor distance, sensor angle. Then they turn to the spot that has the highest concentration of pheromones. They move forward. And they then deposit some more pheromones. After they've all moved, pheromones spread out, pheromones decay, next step again. So you repeat these steps as long as necessary. Hopefully that makes sense and is simple enough to understand. I found this picture helpful when I was setting up my simulations. So if you're trying to code your own Physarum simulation or just trying to understand them more clearly, hopefully that's helped. Now let's have a look at how my specific simulation method works. The first step is to create an array that tracks the pheromone trail intensity at every pixel location. Initially, all spots are set to 0. Secondly, you create a list of particles that have the properties heading, location, sense angle, sense distance, and turn angle. In my case, I set the number of particles to match the image width multiplied by the image height, because that seems to have a nice balance of particle count to image size. Once those initialization steps are done, you can start the main loop. First step in the main loop is to display. For the display, I scale the minimum and maximum pheromone trail values to a value between 0 and 255, and then use that for a grayscale intensity or as an index to a color palette. The next step is that each particle looks at the 3 locations in front of it based on the sense angle and distance, and then you work out which of the left, front, and right spots has got the highest concentration of pheromone. You then turn the particle towards the highest pheromone intensity as shown above in the diagram. Then the particle moves forward by a specified move distance. And the particle then deposits an amount of pheromone onto the trail to increase it. After all particles have moved, the pheromone trail array is blurred. Now for this purpose, I use this quick blur, which is a fast method and allows you to specify a number of passes. The more passes, the more the blur blurs out. And so if you're coding your own simulation, I recommend this blur for speed. After the blur has happened, the pheromone trail evaporates. And then the main loop can repeat as long as necessary. Now that you hopefully have a better understanding of the theory behind these simulations, let's take a look at them in practice using Visions of Chaos. I have a gallery of sample images here. Even though some of these have a 3D appearance, all of these are strictly 2D using the Physarum simulation as outlined in this tutorial. So it just shows you the various possibilities that it can do. Okay, now let's have a look within Visions of Chaos itself. To start the Physarum, go into Mode, Simulations, Physarum, and the Settings dialog appears. Now, all of these settings should now make a lot more sense to you, like the sense angle, sense distance, turn angle, move distance, deposit amount, and evaporation rate. One change in my simulation that is different to the original Sage Jensen code is that I specify both a sense angle and a turn angle. And so the sense angle can be a lot wider, but the particles will have a much shallower turn angle. So let's open one of the sample files. The display drop-down allows you to show the pheromone concentrations or just the particles or both. So let's change that to just showing the particles. This shows the particles by the individual yellow pixels. You can also choose to blur this display so it smooths it out a little bit. But I find the best display is the pheromone concentrations, which is the display that I use for most of my sample pictures and movies. You can also click on this embossed checkbox, which gives the results this 3D embossed effect. And the pheromone blur radius here can be changed between 1 to 5. As the radius goes up from 1 to 5, the blur spreads out more, so you get less detail in the resulting simulations. So if we try one with just a blur radius of 1, it's like this, and if we then bump that up to 5, those trails are much more spread out now. Other than using grayscale for display, you can also use a color palette. So if we go in and have a look at the existing color palettes, and we'll choose a suitable palette, and you want a relatively simple palette for these, not too busy, like a nicely shaded 2 or 3 colors. So for example, let's try this one here, IQ 12. And so that now maps the pheromone intensities. Rather the intensities from black to white, it now uses the color palette. Let's try and find another one. And so you can then choose a more color palette pleasing to what you want. Yeah, and they all give unique results. If you check the Create Movie Frames checkbox, then each frame of the simulation will be saved as a movie frame. I've got some previous frames, so we will just click yes to delete those. So you allow the simulation to run as long as you need to, and then once it's created enough frames, you can just stop it, and then the Build Movie Settings dialog appears. Just click build, and that will combine those frames, and once the movie is built, it will display it in your default movie player. Clicking random sets all of the current settings to random results, so you can click on that and see what happens. And if it's not a pleasant result, you can rerun and click random again. Once you have clicked the random button at least one time and stopped the resulting simulation, you can then cycle through future random runs easily. If you press F4 with your left hand index finger, that is a shortcut for the green play button, and so that brings up the simulation settings. The random button is already highlighted, and so press enter with your right hand. You can then stop it running by clicking F3 with your left hand middle finger. If you like it, save it. If you don't like it, then you press F4 and enter again. And so with these 3 fingers, you can quickly cycle around without having to constantly click and move your mouse around. F3, F4, enter. F3, F4, enter. And so this really saves you time if you are going through a lot of random results and looking for something interesting. And so that's how I found all of the included samples that I include with this mode, hence all of them being called random. So that covers all the features of the Physarum mode in Visions of Chaos. The next idea I had was to expand the Physarum simulation to have more than one type of Physarum existing within the same world. I use 3 different sets of particles here. They all have their own pheromone trail arrays that track the pheromones they use to turn. The main change is in the pheromone detection and turning code. For the single Physarum simulation, the particles look left, forward and right, and then turn and move based on the location with the highest pheromone concentration. For 3 particle types, they take into account their pheromone concentrations, but subtract the pheromone concentrations of the other 2 types. For example, if the 3 trail pheromone arrays are called R trail, G trail, and B trail for red, green, and blue, the red particle pheromones are calculated by using R trail minus the G trail intensity minus the B trail intensity, and then the highest concentration of left, forward, and right is then turned and moved towards, as in the single species Physarum. If you have a look in the Physarum galleries page and scroll down, you'll see I include a few samples of using the multiple species. Once we get past all these single, here we go. And these show the various results I found when I'm experimenting with this method. Okay, so now let's have a look at how this mode works in Visions of Chaos. To open the multiple species Physarum simulation, select Mode, Simulations, and then Physarum 2. Again, all of these settings should now make sense. The sense angle, sense distance, turn angle, move distance, deposit amount, evaporation rate, and blur radius. The only change here is those settings are replicated 3 times for each of the red, green, and blue particles. The random button works the same as in the previous mode. Click random, it'll set the settings to random, and you can repeatedly click random looking for interesting results. Or again, as previously, use the F3, F4 enter trick to go through multiple random results quicker than moving your mouse around and clicking all the time. And you'll also notice that this mode is a little bit slower because it's doing 3 times the calculations. As with other modes, clicking the Create Movie Frames checkbox allows you to make movies from the multi-species simulation. And that covers this mode. The final Physarum related functionality I want to cover is using the Physarum simulation to image process a photo. The only real addition to the usual Physarum simulation is that the particles are each assigned a specific colour. The colour is based on where they start on top of a photo or image. Once the source photo is loaded, the particles are evenly spread over the simulation space and their colours are fixed to the colour of the pixel under them. After this, the particles wander around the image area following the simulation rules with a slight change. In this case, rather than turning left or right based on a pheromone trail intensity, they turn towards the pixel that is closest in colour to themselves. Let's now see how this works in Visions of Chaos. For this example, I will once again be using this photo of Miss Marple. To make sure the photo is not distorted while processing, I will resize the Visions of Chaos window to match the photo size. You will also notice here that as I click and drag the window to a different size, the current image pixel size is shown in the lower right-hand part of the status bar. This helps when manually resizing the window to match a specific pixel size. So here we can get it down to 464. No, jump on, there we go, 464 by 500. Okay. So to use the Physarum simulation as a image processor, select Image, Image Processing, Physarum Pixel Flow. Again, you should now recognize these settings. In our case, we're going to use an external image file. And downloads, we'll use this one of Miss Marple. And let's load, say, swirling smoke, because that has tended to give like a swirling smoke effect in the past. And open. And there you go. It takes the photo pixels, converts them into the particles, and the particles move around, retaining their initial colors. Let's try another sample. Picasso. Okay, another one. try rippling. Okay, let's try making a movie. Let's try the marbled this time. Oops. As always, make sure you select the Create Movie Frames to create the frames, and click OK. We have some previous frames. Click Yes to delete, and off it goes. And so with all the movie generations, let that run for as long as you like, or as many frames as you want. For this test purpose, that should do. Once it stops, the Build Movie Settings dialog appears. And for this one, let's try reversing the order of the frames in the final movie. So this means that it will start at the very marbled appearance and then flow back and finish on Miss Marple. And there you have it. And so let's have a look at running the Physarum image processing on a Visions of Chaos image. So let's change into, let's just do a Mandelbrot fractal. Change the image size back to 720p. Let's pick a louder color palette. Maybe this one. Zoom in a few times to some area with a lot of detail. Okay, let's see how this turns out being image processed by Physarum. We don't want to create the movie frames. This time we want to use the Visions of Chaos current image. Let's open, I don't know, sample 4. See what that does. And so that shows you a few examples of how you can use the Physarum simulation as an image processing tool. Let's just try one more. Processing, Physarum pixel flow. Okay, let's try sample 1 this time. That's a lot more noisy, not too suitable for this. Just regenerate that picture again. Try tight curls. Okay, so that's all of those individual coloured particles as they move around the picture has the effect of smearing out. That now covers all of the Physarum related modes in Visions of Chaos. I hope this tutorial gave you an appreciation for the slime mold and also made you much more comfortable creating Physarum related imagery and movies in Visions of Chaos. As always, let me know if this tutorial was of use, and let me know if there are any other specific topics you would like to see covered in future tutorials. Thanks for watching.